Hi, I'm James. In October 2022, I sat and successfully passed the AWS Certified Security Specialty exam with a weighted average score of 927. And whilst I was preparing for the test, I was on the hunt for some audio-friendly material that I could listen to whilst on the drive to work, whilst doing the dishes, or whilst walking my dog. And what I found is that there's lots of good 5-minute tutorials that focus on a particular AWS feature in depth, but there's not all that much in terms of bringing it all together. So that provides the background and the purpose of today's tutorial. We're going to look at several of the different security technologies that are available to you, understand what they do and how they can be configured. These materials may also prove useful if you're preparing for the SCSC01 exam, but please also do your own research. We're not going to go into quite the level of depth that's necessary for the exam itself, but it should provide a good overview as to what you can expect. And finally, from the materials covered, I'm hopeful that you'll be able to begin to deploy AWS Cloud resources into your account, knowing that you have a number of best practices in place to help secure the works of either yourself or of your teammates. As some background on myself, my name is James Cruddas. I'm a principal consultant with a company called Informed Solutions. We were founded in 1992, so we're just over 30 years old. We have UK offices where we're headquartered in Altrincham, which is a suburb of Manchester, but we also have an office down in London, one up in Edinburgh, and one out in Sydney, Australia. We provide advice and expertise in digital transformation to our clients, so we help organisations use technology and data to change for the better. We're an official AWS partner, and we host several UK government digital services in AWS. Now, the materials that I'm walking through today form part of our Informed Academy curriculum. This is typically reserved for internal staff members only. However, due to the subject matter being security, we're also comfortable to make this externally available so that others can benefit from it. To help structure this talk, we're going to group the areas that we focus on into 3 key themes. So we're first going to look at initial account setup activities and things that you have to do as a root user. We're then going to move on to account level security technologies and how you can configure default settings. This is where we're going to be spending the bulk of the time. And then we're also going to touch on VPC level security considerations, where we'll be looking at things like security groups. We'll be looking at VPC flow logs. We'll come to that section in due time, but this is just to provide a bit of a structure to the narrative. So the first thing that you're going to want to do when setting up a new AWS account is enable MFA on the root user. If you go over to the IAM console, this is actually going to be literally the first recommendation in the list, and MFA stands for multi-factor authentication. Multi-factor authentication is a security pattern where you prove not just that you know something when signing in, so in this case your username and password, but also that you have access to something. That something can take a couple of different formats, so one option is to go with virtual MFA. Virtual MFA is where you use an application to generate a unique 6-digit code, which is time-bound. They normally last about 60 seconds. So you could use things like Google Authenticator, Microsoft Authenticator, or WinAuth if you need a desktop equivalent. And when you sign in, you'll be prompted to provide this 6-digit code. If you provide a valid 6-digit code, then sure, you're let in. If the code is invalid, then you will not be given access to the account at all. So this provides a secondary layer of defense because in the event that your username and password were compromised, unless the attacker also had access to the mobile device or the desktop application to generate a valid code, they wouldn't be allowed in. Another option when looking at MFA is to use a physical USB security device. So these are USB devices which have a unique hardware signature on them, and you must physically plug them into your machine when authenticating into the AWS console. This is actually considered to be better practice because when they're not in use, you can take that device and you can lock it away in a safe. However, do be aware that you do also have to pay for these devices. At the time of recording, they're about £15 to £20 on Amazon. So, you know, if you have mission critical data inside your account, then yes, you should be looking at a physical device. If you're using a development environment and it's purely synthetic test data, virtual may suffice, but really it's up to you to take the appropriate level of security for the purpose of the account. Next up is to configure security questions and alternate contacts on your account. It's amazing how many people skip this step, but it is actually very useful to have these configured correctly. So, security questions are used when you're talking with AWS to prove ownership of the account in question. They're pretty traditional security questions. You can set them up by going to your account management dashboard, and it will be things like, what was the name of your first pet? What was the name of the first school that you went to? But it just helps when talking with support or in account recovery scenarios, just to prove that you are who you say you are. Alternate contacts can also be set for things like security notifications and billing. This can be super useful in an organizational setup. So for individuals, it might always be you who needs to action something. But in an organizational setup, perhaps the billing side of things is dealt with by your finance team. So with alternate contacts, you can basically set their name, their email address, and their phone number so that they will receive notifications alongside yourself when an account action is due. So that could be things like an invoice is ready for payment. Moving on, we have configuring AWS CloudTrail. Now, the name CloudTrail, it's a play on Audit Trail, and it's a service that allows you to record detailed logs of AWS API calls made either by individual users or by AWS services inside your account. This is often a must-have for meeting certain compliance requirements, such as PCI, but these types of logs can also be super useful for diagnostics and debugging purposes. CloudTrail logs not just the who, or the identity that attempted an API call, but also when the action was performed and the specific permission they attempted to use. Because of this last part, if you had an application that's, let's say, received a 401 unauthorized response back from AWS, you can actually use CloudTrail to hone down the specific permissions necessary for an application to do its job. I should call out that CloudTrail is technically enabled on all AWS accounts for free, but if you want to apply security best practice, you're going to look at converting into a costed service. The reason being is that the free offering gives you 90 days of audit trail activity, and you can view these logs by visiting the CloudTrail console dashboard. So if, for example, you had a situation where you suspected a user had been compromised and you wanted to know the cheapest way to see any activity linked to their account, the default CloudTrail settings would do just fine. But there are several use cases where you would actually want to explore the costed option. The first of these is obviously if you needed to store logs for more than 90 days. But the second more compelling reason is if you wanted to trigger alerts based on certain things happening. So when you set up a trail, you get the option to push log content to CloudWatch, which is a log aggregation service. And trust me, CloudTrail generates a lot of logs. So you want something where you can easily query and visualize log events. You can then configure CloudWatch to look for certain patterns. So for example, if your root user was logged in. And because of its tight-knit integration with AWS SNS, or Simple Notification Service, you can configure things to send an email or text to a colleague letting them know that something has happened, which, if they weren't expecting it, could indicate a possible security breach. Some options that you might want to consider when you're setting up CloudTrail are whether the trail itself will be multi-region. The main difference here is that multi-region records all actions in all AWS regions versus one specific region. If you don't know which option to go for, choose multi-region by default. There are no guarantees that an attacker would happen to choose to perform malicious activity in your preferred location of choice, so choosing multi-region gives you a good view as to what's going on in the entirety of your AWS account. Second is whether to ship logs to an AWS S3 bucket. This is definitely worth turning on, as you can use this setting to push logs even to other AWS accounts. In the event of disaster, so let's imagine your account was breached. If you had your logs in the same account, you do run the risk that without necessary precaution, they could just be blown away. By shipping logs outside of your account, so to a different location, you've got that guarantee of having a backup and a much fuller story describing all of the actions taken and by whom if worst came to worst. If you do choose to ship to an S3 bucket in the same account, which you can do, the key piece of advice here is to enable MFA delete on the destination S3 bucket, and you can only do this as the root user, which is why I've included this in the section of the tutorial. So earlier on, when we spoke about enabling MFA for root login, the same principle applies here. But this time, MFA is used in relation to modifying the settings on an S3 bucket or deleting objects from a particular bucket. A quick note here is that you can only apply this setting using the AWS CLI or the command line interface, so please do have a look at the documentation for how to do this, because there are quite a few parts to the command. You should also consider enabling the log file validation setting when setting up a trail. When this option is enabled, a signature of the log content gets shipped alongside the logs themselves. In the event of compromise, any half-decent attacker would clean up after themselves and remove any log entries that recorded what they were doing. But by having this log file signature, you can basically assert that the log file content you're viewing matches that which was generated by AWS at the time, so you know it's a like-for-like record. AWS customers also have different options they can choose from in terms of how they want to encrypt log file content. So when shipping logs to S3, you can either choose SSE S3, which is S3 server-side encryption, which is the default, or you can use KMS. KMS is the AWS Key Management Service, and by choosing this option, which will create a customer managed key, this will afford you a little bit more control over the cryptographic material used to protect your log files. We'll cover KMS in a bit more detail shortly, but for now, just know that this is technically the more sophisticated option to choose. Once CloudTrail's set up, ideally you'll have proactive notifications firing on different security events taking place, but it's also worth scheduling a periodic review of your CloudTrail logs, just to make sure there's nothing unexpected going on in there. As a nice to have, you can also configure something called CloudTrail Insights, which gives you access to a set of pre-built dashboards that you can use to help you in this process. Finally, one of the last actions we should consider as a root user is how others beside ourselves will authenticate into our AWS account. At a high level, you have two main options. Either use AWS IAM identities, which is the Identity and Access Management Service and requires that administrative users set each individual up one by one, or you could choose to use an SSO or single sign-on setup where you integrate your AWS account with an existing identity provider. If you're in an organizational setting and everyone in your account is going to be coming in from the same identity provider, an SSO setup is for sure the way to go. You can configure your AWS account to use an identity provider, whether it's Active Directory, Okta or similar, and that means that you can centralize authentication and authorization. This reduces the risk of unauthorized access as you can tap into an existing JML, or joiners, movers and leavers process, which typically come with group assignment. So if someone joined your organization and is assigned to a particular business unit, you can set things up so they automatically get access to AWS by signing in with their domain credentials, as well as the respective permissions they need to do their role. There's also a proxy benefit to this in that users only have to remember one password, and things like password complexity requirements, alongside how often they may need to change their password, will already be established in line with your organizational policy. There are a few technical pieces that need to be put in place for this to work. If you have network restrictions, for example, Choosing this option won't magically adjust your firewall settings, and you also need to establish something called a trust relationship between your identity provider and AWS. When I took my exam, AWS SSO was the preferred option of choice, which required a unidirectional inbound trust from AWS to an identity provider. Now, the way that I remembered this for the test was to basically reverse the direction of travel for authentication. So if you're authenticating out into AWS from, let's say, your on-premise Active Directory credentials, you would need to have an inbound trust created between AWS as a relying party and your identity provider of choice. Now, a big warning and disclaimer: since I took my exam in October 2022, AWS SSO has been superseded by IAM Identity Center. You can still set up a similar configuration, but you must have a bi-directional trust relationship, meaning it goes both ways. The inbound trust allows users to authenticate out into AWS, and the outbound trust, so in the opposite direction, allows AWS to read user and group metadata to help keep things synchronized. Something that took quite a while to sink in is that when you're using single sign-on configurations, user permissions are mapped to IAM, or Identity and Access Management, roles, not groups. This is quite nuanced, and something that if you're watching in preparation for the SCSE 01 exam, you really need to dig into. The other option mentioned earlier is you can also manage identities exclusively within AWS IAM, which also has its own use cases. Let's say, for example, you were working with teams across multiple organizations. Now, realistically, you might not want to model each individual user from each individual organization in your identity provider setup. If you do choose this option, a quick hint is to set up their username as their email address. Now, technically speaking, IAM users can pretty much have any sensible username, but if you need to reach out to them, for example, to let them know that their access keys are due for renewal, you want to avoid having to spend time trying to figure out who user_1 might be and where to send that message. If you use their email address, it's just a much easier process and you know directly who to contact straight away. If you have chosen to go down the path of setting up your own IAM users, I'll briefly touch on groups, roles, and policies. The best description I have heard to describe the difference between these concepts are that groups are collections of people, so actual human beings. Roles are an identity that can be assumed by either humans or an application, and this is a key distinction. And policies are the rules that define who can do what. If you're studying for the SCSE 01 exam, you need to know the difference between these inside out, because trust me, they will be on the test, as well as the various condition statements that you can apply in IAM policies. For example, you can have policies that limit access to a specific named user, to a named IAM group, a particular role. You can also have more nuanced scenarios where you define access to a specific source IP address or even specific times of day. You can make these policies super granular and even go to the next level through something called permissions boundaries, which is where you control what delegated permissions people can give to others. And if you're sitting the exam, you need to know things right down to the specific syntax required for each scenario. For listeners who might be new to AWS, you'll be glad to hear there are AWS managed policies which ship out the box and have been built on predefined job roles. So for example, there is a pre-configured AWS administrator policy that you can begin to assign. Now, I've intentionally not said the words assigned to users because assigning policies directly to users is actually not considered to be good practice. If you're dealing with humans signing into an AWS account, the better option is to place those users into a group, which, as we covered earlier, is a collection of people, and then assign policies to that group. This simplifies management because if you can see that a user belongs to a group, that avoids a situation where you have to trawl through their permissions individually to work out what they have access to. If they only have access to a group, then they only have the permissions assigned to that group. Whichever option you choose to go for, be it single sign-on or IAM managed identities, the last and final action that we have to do as a root user is set up a general day-to-day account that we can use to manage our AWS resources. Where we want to get to is that we have an account, either by SSO role assumption or as a named individual IAM user account, that has the AWS administrator policy assigned to them. Once that's in place, we're hopefully now never going to need to sign in as root user again, and we can keep the credentials for this account under lock and key only for use in emergency scenarios. Now we've set everything up that we need to as root, we can continue to strengthen our cloud security posture using technologies we can configure using just our administrative account. Something to call out just in case it's not obvious is that with your new admin account, one of the first activities that you'll want to mirror from our earlier steps is assigning an MFA device to the new account. As a good practice, to help make sure that this gets replicated across all users you set up in the future, you can configure an IAM policy and then attach it to a group, and then place all future users that you create into that group, so that subsequently they have to authenticate with MFA before they can do anything. If they haven't authenticated with MFA because it's the first time that they're accessing their new account, the only permission that they'll be allowed to support is assigning themselves an MFA device. There are detailed steps on how to do this, which you can find on the AWS Knowledge Center, but it's well worth doing because it puts you in good stead. Now, assuming it's not just yourself using the account, as an admin user, you can create accounts for others, you can configure IAM policies, as well as set up different groups and different roles. When doing so, you should always work with the principle of granting least privilege. Practically, this means assigning specific service permissions against specific resources. So try and avoid any wildcard technology permissions or resource assignments, which you'll be able to see because they use a star character. Whilst yes, this does take a little more time to craft more tightly scoped policies, after you've created a few, you will get the hang of it. You can also speed up development and testing of IAM policies using the IAM Policy Simulator. The IAM Policy Simulator is a tool that allows you to test and validate the permissions of an IAM policy before you attach it to a user, a group, or a role in your AWS account. It allows you to perform a series of simulation tests to see how the policy is going to behave in different scenarios, so when assigned to, let's say, different user groups. It will also help you understand how that policy is going to behave when paired with other policies that may have already been assigned. Whether you're new to AWS or you're an experienced pair of hands, it's definitely worth checking out because it gives you that confidence that the policies that you've generated are going to work. It can help to cut out any back and forth with users who you might be administering, who are frankly just trying to do their job, but end up getting met with console errors telling them they aren't allowed to do something. Before we move away from talking about IAM, I should mention a few more key features that you should know about from a security standpoint. As a user in the AWS administrator role, if you have chosen to manage your identities as IAM users, not using a single sign-on solution, in the account settings menu of the IAM console, you can configure your account's baseline password complexity and rotation requirements. For example, you can stipulate that passwords have a minimum length of anything between 6 and 128 characters. Then additionally, you can enforce complexity rules that require they contain a mixture of lower and uppercase characters, numbers, and symbols. You can also turn on password expiration and prevent the reuse of passwords. Whilst NCSC guidance, the National Cyber Security Centre in the UK, has evolved over the years, As a tip, having been through many penetration tests, you should turn on both of these options and set the password reuse restriction to its maximum. This will prevent people from reusing any of the last 24 passwords they have assigned to their account. A few additional settings to know about is that you can choose whether or not to allow users to be able to change their own passwords. You can also configure whether an administrator needs to get involved should a password expire for a given IAM user. That is, they don't change it in the agreed timeframes for your policy. These have different levels of administrative overhead attached to them, so configure what's right for you. But generally speaking, allowing users to change their own passwords is typically a good thing. It enforces good security practice. Requiring an administrative user to reset passwords is a bit more debatable. If it's something that's very sensitive, you might want to turn this on, but be aware that an admin will have to get involved and that will require people's time. Another feature to be aware of is IAM Access Analyzer. IAM Access Analyzer assesses resource-based policies and can generate a summary of findings that details what is currently allowed and by who, that you can then use to ensure your resources are only accessible to the people or services that you intended. You can use the service feature to identify resources that are publicly accessible, including those with, let's say, open permissions, so things like S3 buckets, and resources that can be accessed by unknown or unintended principals, which generally suggests a misconfiguration. Access Analyzer also provides recommendations on how to go about limiting resource access and configuring policies based on best practice, so it's a good thing to use just to keep tabs on making sure that there's no accidental misconfiguration at play in your account. There's also a feature where you can download a credential report, which shows you users that have access keys enabled, when they were created, when they last changed their password, and so on. Some use cases for this are you might want to run periodic checks to make sure that people aren't, for example, generating access keys and then letting them go stale. So they might have generated access keys and then they're left unused for hundreds of days, and this feature will help you to identify those particular scenarios. Now, I found it slightly surprising that IAM doesn't actually have a way to automatically enforce the rotation of access keys, but there are a few things that you can do here. The credential report is also accessible through the AWS SDK, which under the hood calls a REST API. And what that means is that you can get an equivalent representation of the report by downloading it in code, so running in a service such as AWS Lambda. This means that you could script steps on what you want to do in certain scenarios by, let's say, removing access keys immediately, or you could send an email to a user if they've exceeded your particular preference, using something like SES, which is the simple email service in AWS, to let them know that they need to rotate their keys. From there, you could do whatever logic best fits your use case. So you could, for example, give them a warning on day one of their key going past your rotation schedule, and if they didn't do anything about it, you could delete their key after day 7. For any avid listeners, if you recall earlier, I mentioned that setting IAM usernames to people's email addresses is a good idea. And this is a prime scenario for where this could be useful, as you could send that polite but firm reminder to the email address that was given for their username. There are other ways that you could do this, so you could use things like user tags, but from experience, email addresses as usernames is the simplest option. It requires the least amount of setup, and you know it's always going to be unique, so it helps with automation, which is always a good thing. Other things to note are that you can check service control policies and organization activity through the IAM console as an admin user. These are both relevant if your account is enrolled in an AWS organization, which is super useful if you are managing multiple AWS accounts. There are a number of reasons that you should enroll in an AWS organization if you're in a business setting. At a minimum, you get the benefit of being able to view consolidated billing, so you can see a breakdown, for example, of bills and usage per account all in one place. But you can also set global permissions that you want to apply across all of your AWS accounts using service control policies, or SCPs. The IAM Organization Service Access Report is a feature that enables account owners to monitor and audit the use of AWS services within their organization. This feature generates reports that provide a summary of the AWS services that have been accessed within an organization and by which accounts, including your own. So if you're in an AWS organization, you can use this feature to see which accounts also inside your AWS organization have accessed your resources. Touching on service control policies, or SCPs more specifically, this feature allows you to set granular permissions and restrictions on the use of AWS services across your AWS accounts in an AWS organization. SCPs work alongside IAM policies, and they're used to establish a baseline of permissions for all accounts in your organization. SCPs enable you to restrict access to certain AWS services, actions, or resources at the organizational unit, or OU, level. An OU is a container for accounts that share a common set of policies. So when you set up a new account, you can place it into a named OU, for example, development or production, and the account automatically has all of the rules defined in your SCP applied to it from a single policy definition. There are two ways you can configure SCPs, or service control policies. You either list individual permissions that you want to deny, or things that you want to allow. By default, and something you really should stick to, otherwise you could face a maintenance nightmare, SCPs are modeled using an allow followed by an explicit deny policy model. Your base SCP will have a global allow rule, so allow star. Then you can add alongside this explicit deny rules. As an applied use case for an SCP, if you're based in the UK, you might want to block off certain AWS regions other than London or Ireland, and maybe North Virginia, which, as a side note, you will need if you're using CloudFront. So your SCP could contain a global allow rule for all actions, then prohibit any actions outside of these regions. You can also build up SCPs the other way by denying everything, then granting specific allow rules one by one, but this becomes a bit of a maintenance pain, as each time a new AWS IAM permission, so let's say a new service is released, when that becomes available, you will then have to update your SCPs. Scale that out across a number of accounts, and you can probably see why this becomes a bit of a pain. A final point on SCPs that you should be aware of is that they are hierarchical and they're ordered when assessing evaluation rules. So in an organizational setup, if you have an SCP with a deny statement applied to an account in an OU that sits under the root level organization account, it doesn't matter if that top level root SCP has an allow for the same permission or not. IAM assesses the rules bottom up. So it will first look at the SCP attached to your account, and will use the first deny policy that it comes across to make a judgment on whether a permission should or should not be allowed. The last thing that I'm going to mention on IAM before we move on to different AWS services is its neat integration with CloudTrail. There are two main things here. So first is Access Advisor. In short, you can look at a user or group and get a quick snapshot of what permissions a group or individuals have been afforded, and you can see when they last accessed a service. This can be useful in checking whether users actually still need certain permissions or not, or whether you could take them away. The final point is that for specific IAM users and roles, but not groups, if you click on the user or role name in the console, as a feature of IAM Access Analyzer, you can generate a proposed policy on the given identity's CloudTrail activity over a period of time. Again, in my opinion, this is a feature which remains a little bit of an unsung hero. Let's say you have an application that needs to do certain things with other AWS resources. Best practice is you model those permissions into a role, which the application then assumes. As a quick note, this means it gets assigned temporary credentials with the appropriate permissions to do its job. You would be amazed if I told you the number of times we've inherited a solution where fixed IAM user credentials have been set in application code to give it the permissions that it needs to work. This can be a real pain, as when this kind of hacky job is put in place, it also tends to come with some super open permissions that give the application access to pretty much every resource and permission you could think of. And this is where CloudTrail Events integration comes in super handy, as through the IAM console you can just by the click of a button automatically create a policy to be assigned to a role, not a user, based on activity that has been observed in CloudTrail over a given period of time. By using that proposed policy, I mean, obviously you should run the proposal in a development environment and test your application still works, just to make sure that the new policy hasn't, lost any permissions that it needs. But on the whole, this feature can give you that added boost of confidence that the policy implemented all tallies up with the evidence that's been seen in CloudTrail from a production environment when you're making the switch. Moving onwards to automating, implementing, and monitoring a whole bunch of account-level security checks, we have Security Hub. If there is one AWS technology that you're going to enable at the account level, this should be the one, as it not only gives you a summative view on your overall security posture based on current state, but it provides you with a platform where you can learn how to continually improve your account security. The best way to think of this service is as a wrapper around other AWS services, and it can help to call out findings and help you prioritize on what to focus on next. It is a paid-for service, but does also come with a 30-day free trial. So you could, in theory, check its findings, remediate any issues that you've come across, and then opt out if long-term billing is a concern. Security Hub pulls in findings from the following other AWS services, each of which we'll come on to talk about in a bit more detail, but these are namely Guard Duty, Inspector, Systems Manager, AWS Health, Config, Firewall Manager, IAM Access Analyzer, which we've already talked about, and Amazon Macie. Some reasons that you might want to consider using AWS Security Hub are: it simplifies security management, so Security Hub provides you a single place to view and manage security alerts, compliance status, and manage security configurations across all your AWS accounts. This helps to simplify security management and reduces the amount of time and effort required to maintain a secure and compliant infrastructure because you can see it all in one place. You can configure Security Hub against different benchmarks, starting with things like AWS Foundation benchmarks, but you can also run it up to much tighter controls, for example things like PCI DSS version 3.2.1. The feature I've found most useful is that if you do fail a check, Security Hub will actually point you towards documentation on how to fix it, with instructions that go into a good level of detail, right down to what you should be clicking in the AWS console, or if you're using IAC, how to remediate this in things like CloudFormation. The second reason for using AWS Security Hub is that it continuously monitors your AWS environment for security issues or compliance validations. I stress the word continuously because every, 24 hours, Security Hub is periodically refreshing and checking the status of your resources against current best practice. That means that it's able to work in the night while you're asleep and is scouting your account to make sure that your resources are in the best possible position in terms of being protected against known threats. If you're looking for super bonus points, you can even hook security up with things like AWS Lambda and SES to send you a weekly summary on your overall security position, or you could go really fine-grained and ping an email through when a benchmarking rule has been passed or failed. Third reason for using the service is that you can integrate with third-party solutions. So the service integrates with a wide range of third-party security solutions, including vulnerability scanners, SIEMs, and threat intelligence platforms. This means that you can leverage your existing security investments, if you already have them, and extend the value of AWS Security Hub above and beyond what it can achieve natively. Final point is it's pretty cost effective. So Security Hub is cost effective in that you only pay for the features that you use. There's no upfront costs, there's no minimum fees, and you only pay for the number of resources that you monitor. We're now going to dig into some of the technologies that Security Hub monitors so that you know what each of them does in turn, and if you wanted to, you could customize them further based on the particulars of your use case. So first up, we have Guard Duty. Guard Duty is a threat detection service that monitors your AWS accounts and workloads for malicious activity and unauthorized behavior. Now, a key selling point of Guard Duty is that it uses machine learning for anomaly detection paired with threat intelligence to identify possible risks in real time to your workload. Now, with it being machine learning backed, there is a training period, so it does come with a 30-day free trial, and if after that you feel it's still bringing value to you, you can choose whether or not to continue with the service, which would highlight to you any deviations from the baseline norm, either through the console or through alerts which you can configure using CloudWatch and SES. Next up, we have Amazon Inspector. Amazon Inspector is an automated vulnerability management service that continually scans workflows for software vulnerabilities and unintended network exposure. The two main resource types where Amazon Inspector adds value is if your application is deployed on EC2 instances or using Docker through the likes of ECS, whether it be Fargate or across an EKS cluster. Amazon Inspector can also support Lambda packages, so if you're going for a serverless setup across, say, ECS and Lambda, it's a great service to use. At its core, Inspector scans for OS-level security vulnerabilities, so say a missing Linux or Windows server patch, and application-level dependencies in, at the time of recording, Java, Node, Python, or Go. To use a very popular example from recent years, Inspector would, for example, pick up the log4j vulnerability widely reported by inspecting jar files on either the EC2 instances or containers based on images stored in an ECR registry. A key thing to be aware of is that when you are setting up an Elastic Container Registry, you can choose an option to scan images on push. So basically, run a scan whenever new images are pushed to the registry. But a key difference between this setting and Inspector is that ECR image scanning is event-driven. That is, when you push a new ECR image, it gets scanned for free under the basic scanning setup, which is great, as it avoids you pushing any newly identified issues up to production. But Inspector is capable of back-testing older images too. This could be important because you might have a production Docker image that is running at least a few tags behind your current development branch. Inspector adds that extra level of insight because it can test your older images and will let you know whether your production instances, which, let's be honest, are the ones that you care most about, are susceptible to any disclosed CVEs. We're now going to talk about Systems Manager. System Manager is a service that helps centralize things like patch management. It can test for the presence of patches and apply them across a number of EC2 instances to help make sure that you're in check with your intended baselines. Systems Manager can also be used to push things like software packages out to a fleet of target EC2 instances, so it's capable of doing more than just OS level patches. Because you might be dealing with sensitive parameters when applying machine config, Systems Manager, or SSM for short, does also come equipped with its own means to pass down secrets, so think about things like passwords or API keys, to target resources in a secure way using a feature known as parameter store. SSM parameter store is very flexible and can be used for passing data, so that could be config files, it could be license keys, either encrypted or unencrypted. AWS Secrets Manager, on the other hand, which is another service to know about, is a dedicated service for secrets management based on a pull mechanism. So your applications talk to Secrets Manager over a REST API and they pull secrets in. Secrets Manager provides some additional capabilities beyond SSM, such as automatic rotation of secrets, so think things like RDS credentials and passwords, and by default everything gets encrypted with KMS when you're using Secrets Manager, which isn't always the case when using SSM. If you're weighing up the two and you don't know which way to go, if a credential doesn't change frequently, so think production API key, and you don't require any advanced features offered by Secrets Manager, such as automated rotation, SSM might be a simpler and more cost-effective option for you. If you're storing large amounts of secrets, and I'm talking hundreds or thousands of secrets, again, SSM would probably be the way to go because it's slightly cheaper in terms of how much it costs per secret. Generally speaking, if you have an app that needs to retrieve a secret on demand because it can change frequently, go for Secrets Manager. If you had, let's say, a fleet of IoT devices where you need to push credentials to thousands of consumers, go for SSM. You could automate this with a job to push those secrets down to the devices. If you had a server-side app that needs to fetch a DB password that could change at any time, go for Secrets Manager. You'll have picked up that there are some nuances between these use cases, so if you're studying for the SCSE01 exam, I would recommend reading a little bit more into this area and just knowing when to pick each option. Before we leave Systems Manager, the other very useful feature I'll call out is Session Manager. Sessions Manager allows you to create an SSH connection for Linux or RDP for Windows to EC2 clients, all from within inside your AWS account, and more so within your VPC. To cut a long story short, when we look at NACL rules later on in our VPC level considerations, as a rule of thumb, you should deny inbound firewall rules on ports 22 for SSH or 3389 from just anywhere, so a blanket 40 address space. This is because these are privileged ports and you want to avoid exposing opportunity for people to connect straight to the heart of your application if you have an EC2 instance set up, especially if it's running in a public subnet, which is not a best practice but is sometimes required. By using Sessions Manager, you can actually create connections over SSH or RDP to manage and maintain those EC2s without compromising on our network connectivity rules. A few quick caveats are, you do have to install the SSM agent on targets that you wish to connect to, but there are very detailed AWS document steps that you can consult on how to do this. Next up, we have AWS Config. So config allows you to assess, audit, and evaluate the configuration of your AWS resources, namely at the infrastructure level, but on a continuous basis. It helps you to monitor and track the configuration of your resources over time and ensures that they comply with your organization's policies and compliance requirements. With config, you can automate evaluation of your resources and receive notifications when any configuration changes are made. This helps you to understand how your resources are being used, who may have made changes, and when those changes have been made. Additionally, config provides a complete inventory of all of your AWS resources, making it easy to audit and track changes. Config also provides you with a rules engine that you can use to define custom rules for evaluating the config of your resources. You can use these rules to ensure that your resources continue to comply with any specific regulatory or security requirements. A key thing to know here is that it does go above and beyond IAM Access Analyzer, which we spoke about earlier, as Access Analyzer is limited to monitoring and testing IAM policies. Config, on the contrary, can be used to do things like check security group rules don't result in your resources being publicly routable. To draw an applied example to help distinguish between config and Access Analyzer, Access Analyzer would do a great job in telling you whether your S3 bucket's access policies allowed the general public to do things like upload files, which you most likely don't want, but it can only tell you this because it works off IAM policy syntax. AWS Config, on the other hand, could tell you if, let's say, specific EC2 instances responsible for running your application were directly addressable without first going through a load balancer by their public IP, which is something you normally don't want. The main thing to know about config is that you can automate the evaluation of your resources and receive notifications when any configuration change is made or drifts away from your baseline. So a great example would be if someone tried to configure an inbound SSH connection to an EC2 over port 22. If you spend the time to set up AWS config, you can work with automation using things like custom Lambda functions so that whenever these types of activities are detected, you can automatically remediate them by removing the likes of inbound rules for SSH over port 22. Moving on, we have Firewall Manager. Firewall Manager is a kind of wrapper service that sits around AWS WAF, or Web Application Firewall, Shield, security groups, Route 53 DNS firewall, network firewall, and can also work with third-party firewall products. Its key offering is that it provides a one-stop shop for anything firewall related, and you can easily manage firewall rules across multiple AWS accounts and different resource types. A few use cases where you might want to use this service would be, for example, you want to deploy WAF rules across all load balancers, API gateway instances, or CloudFront distributions used by your organization in one go and manage them from one central location. You might also want to, say, block a specific port on all AWS security groups as a blanket rule across all your accounts, which you could also do using Firewall Manager. Main takeaway is that if you're looking to manage WAF configurations, anything firewall related, or security group rules across multiple AWS accounts, Firewall Manager can help you with that. Last on this slide, we have IAM Access Analyzer, but because we've already covered Access Analyzer in a reasonable level of detail, we're going to skip over this one and just move on to our next slide. Continuing us on with account level security, we have Amazon Macie. This is the final technology that Security Hub wraps, and Macie's main use case is for identifying and protecting sensitive data stored in S3. It's an AI-enabled service that scans file contents for PII, or personally identifiable information. It then provides a detailed inventory of your data and identifies any potential security risks or threats to that data. If PII is found, it can automatically apply data security policies to help you protect the data. These policies can include access controls, data retention, and different types of encryption. This can be very useful for compliance, but also sometimes you could have cases where you might just not know if PII is present in certain datasets, especially if they're user supplied. So you can get Macie to identify that for you. A final point on Macie is that you can also get reporting from the tool to track data access and usage across your AWS environment. So to recap on Macie, if you're tasked with identifying and monitoring PII in S3 contents, Macie is the right tool for the job. So that covers some of the key account technologies to be aware of when working with Security Hub. Security Hub is basically providing you a managed service that helps wrap all of these findings up and provide you with insights and instructions on how you might be able to remediate any findings. In that way, it can also act as a type of training tool if you continue to monitor and take actions based on new results coming out of Security Hub. A few things I do also want to cover before we close out the part of today's session on account level security are: there is some overlap between Security Hub and a service called AWS Trusted Advisor. Trusted Advisor looks at all areas of the AWS well-architected framework, one of these which is security, so that's why we see a bit of an overlap between the two. The difference is that Trusted Advisor will also take into account things like cost optimization, performance, fault tolerance, and service quota limits that might be running in your account. Another service to know about is Amazon Detective. Detective helps users investigate and identify potential security issues in their AWS resources. It provides a unified view of resource behavior and helps users visualize security relationships between resources. Detective uses machine learning algorithms to analyze log data from services like GuardDuty, Amazon Virtual Private Cloud Flow Logs, and Amazon CloudTrail. It then generates visualizations and graphs to help users identify patterns and anomalies in their AWS resource usage. So very helpful if you suspect you might have a security incident at hand, as it avoids needing to manually trawl through what can be some quite large log files by hand. Depending on the type of technologies you're using, you can also often set up defaults for things such as whether encryption will be applied on a resource being created. As a prime example, there's an account and more specifically region level setting for EBS, Elastic Block Store, which is commonly used with EC2 instances for virtual disk partitions. By turning that setting on, you know that all EBS volumes will be encrypted by default. It's always worth having a look at the options available for your particular technology choices and seeing if there are any global settings that you can apply to avoid having to rely on people remembering to enable encryption. You should also understand and agree a position on what level of encryption protection and control you need for your use case. Nearly all encryption in AWS is tied to its key management service, or KMS. In KMS you have different key types, each of which come with their own differing levels of protection and control. Starting with the simplest, you have AWS managed keys. These are, as the name suggests, managed by AWS. They get rotated once a year, and they get created automatically if you use the default encryption option for a service, like RDS for example, in your account. You can view the key policy, which defines what services can make use of it, but you can't change it. If you needed more fine-grained control, this can be problematic. So there's the pro that they're super simple to create, but that comes with the con that you don't really have any control over them. As a side note, you also have something called AWS-owned keys, which you never actually see, but these get used for things like S3 envelope encryption. These aren't account-specific, and if you don't have any compliance requirements, are a good simple choice. You've then got customer-managed keys, which give you more control on defining the policies of when a key can be used. You can choose to rotate these automatically once a year, but you can also rotate these manually by creating a new key and updating a key alias pointer. Finally, you've got Cloud HSM. HSM stands for Hardware Security Module. This type of key material handling is a bit more specialist, but this service gives you guarantees that your key material is securely stored and backed by hardware in a way that not even AWS can access. This option has become a little bit cheaper over recent years, as it used to have an upfront cost of about £4,000 to £5,000 for the hardware provisioning, but that's since been removed. The main use case here is if you need to comply with more stringent compliance requirements, such as those that come with PCI DSS. A keyword to watch for if you're sitting the SCSC 01 exam is that if you see any requirements for FIPS 140-2 Level 3, Cloud HSM would be needed, as KMS only supports FIPS 140 Level 2. Cloud HSM is definitely a more expensive choice and quite reserved to specific use cases. Another quick pointer if you're studying for the exam, you will need to know each of these key types in a good level of detail, as well as key grants, which you can use to allow people to use keys, unlike the policy which defines the conditions under which a key can be used. And that just about covers the main account level technologies you should be aware of, but it's also worth calling out this is not an exhaustive list, and new services are released quite frequently. A great way to find out about new services is by listening in to AWS Reinforce, which is a recurring conference where guest speakers and AWS teams showcase progress in cloud security. We're now going to take a look at some key VPC level security considerations. A VPC, or Virtual Private Cloud, is basically an isolated virtual network into which you can deploy cloud resources. If you visit the EC2 console and then choose VPCs, you'll see that your account actually comes with a default VPC in each region out the box. However, a tip here is that you should always look to create your own VPC for your resources instead of using the default. The default VPC often gets selected when using setup wizards or CloudFormation templates, but it should not really be used for any production workloads. Just one example of why is by default it comes with the assignment of public IP addresses in public subnets, which is not a good security practice. You also don't really get any real flexibility around things like CIDR ranges, and there are some limitations with its use when it comes to working with AWS services like Transit Gateway. A custom VPC gives you more control over things like whether you want your VPC to support DNS hostname resolution or not. Don't get me wrong, the default VPC is great for things like training, deploying a few services just to see what they do, or if you're doing some quick prototyping, but it's generally not a good idea for production use. At the VPC level, you should also consider creating subnets in multiple availability zones. An availability zone, or AZ for short, is a geographically isolated data center in a particular region. So to support high availability, you will normally want applications deployed across multiple AZs. Resource types like application load balancers and RDS have configuration settings where you can choose different subnets dispersed across different AZs. And in fact, for an application load balancer, you have to spread over more than one AZ. You can also configure the likes of EC2s, Lambda functions, and so forth to run across multiple AZs, all through the AWS console, using the CLI. You could use CloudFormation, or you could use other IAC tools like Terraform. When you're designing your network and deploying resources, you should always opt for a model of preferring private subnets as the default deployment location. This is especially true for things like application servers and databases. Generally speaking, there's not that many resource types that have to be deployed to public subnets, except those which need to be internet routable, so load balancers are a good example. I'm not going to stray too far into network design, but you can still achieve things like internet connectivity from applications running in private subnets by making use of NAT gateways and route table entries. Whilst on the topic of network connectivity design, a few quick technologies to call out that you should be familiar with if you're planning to sit the SCSE 01 exam are Direct Connect, which is used to set up a VPN between your on-premise network and AWS, VPC peering, which allows VPCs to communicate with one another, Transit Gateway. This also allows for connectivity between VPCs but using a hub and spoke model. Egress-only internet gateways. These allow IPv6 traffic out but not in. And finally, internet gateways, which allow instances with public IPs to access the internet. Note, these are different to NAT gateways, as NATs are for use when connections are being made from instances that do not have a public IP. Next, we have NACL rules, or Network Access Control List rules. NACL rules are associated with the VPC and act as a firewall for controlling incoming and outgoing traffic to and from subnets in your VPC. You can create a series of rules which get evaluated in a priority order to either allow or deny traffic from CIDR ranges, so you can limit things at lower level subnets if you need to. Note that a key difference between NACL rules and security groups, which we'll come on to next, are that NACL rules are stateless. That means that just because you've allowed traffic in on a certain port, it does not mean that it's allowed out by default. Security groups which are stateful don't need a separate routing rule added to allow return traffic. As a general recommendation, I would suggest adding to the default allow rule on your NACL group setup, specifically to block off ports that you don't want any traffic coming into your network on. Some typical rules that you might want to add would be denying port 22 and 3389, so that's SSH and RDP inbound. Something to also know is that just because traffic came in on a specific port, so let's say port 80 for HTTP or 443 for HTTPS, it will not necessarily go out on that same port. To allow return traffic for connections over HTTPS, so for traffic to things like elastic load balancers, you will need to allow ephemeral ports outbound, as this is what the traffic is actually returned on. In most cases, you will want to allow ports 1024 to 65535 outbound, because this is the range that's used by NAT gateways, load balancers, and Lambda functions. We have security groups, which are slightly more versatile than network ACLs due to their ability to perform stateful packet filtering, and you can create rules that reference other security groups. So a key difference between security groups and NACLs are that NACL rules apply to subnets, whereas security groups apply to instances or specific resources. Security groups work on an allow model. By default, when you create a security group, no traffic will be allowed in or out. You then have to add allow rules to let traffic pass through to the resources that reside inside a security group. When creating security group rules, you can use IP addresses if you want to, but as mentioned earlier, you can also set up rules between security groups using their security group ID. So you might, for instance, have one security group for an application server, another for a database instance, then allow traffic back and forth between the two by referencing these security group IDs. This is very helpful when you might not know the IP of a particular resource in advance if you have things like auto-scaling enabled. Security groups are different to NACL rules, but they do work together. If you have an allow rule on a security group that is blocked at the NACL level, traffic will be denied. Equally, just because you have an allow rule at the NACL level, that doesn't mean you automatically get an allow rule at the security group level. Because security group works on an allow model, and you actually can't create deny rules with security groups, if you wanted to block incoming traffic from a certain IP, you would have to do this with a NACL rule instead of a security group. A last note on security groups is that you can add and remove rules at any time. Your changes will be automatically applied to all of the instances that are associated with that security group. You can also assign multiple security groups to an instance, but this can become a little difficult to manage, so try and keep your security group rules as condensed as possible, and have security groups set up so that they focus on distinct types of resources, i.e. don't try and just have one big security group that tries to do everything. Some final key technologies and settings that you should be aware of at the VPC level are VPC endpoints. So when your application communicates with AWS services using the SDK, under the hood this uses the public AWS APIs for doing so. Very practically, that means that even if you have an application running inside a VPC, if you were, for example, uploading a document to S3, it would actually go out through a NAT gateway to the public internet, then over to S3. If you have a requirement where traffic should not be leaving the network perimeter, or you simply don't have NAT gateways, you could still access AWS services by using VPC endpoints. VPC endpoints effectively provide a route to AWS services without needing to go out over the public internet. They are a costed service and their pricing model is billed per hour, and they're not really something that you can just turn on or off, so they're very good to use from a security standpoint, but to keep costs down, you should only really be deploying VPC endpoints for the actual services and technologies your application uses. Next, we have VPC flow logs. Flow logs allow you to capture information about the IP traffic flowing in and out of your VPC. Flow logs can be used for a variety of purposes, including security analysis, compliance auditing, troubleshooting, and network forensics. For each network connection, VPC flow logs capture the following information: the source and destination IP address and ports, the protocol that's used, so TCP, UDP, or ICMP, the amount of data that's being transferred in each direction, the start and end time of a flow, the action taken on the traffic, so whether it was accepted or rejected, the network interface through which the traffic passed, and the traffic source and destination, such as an elastic network interface or a public IP address. Because of this level of detail, you can use VPC flow logs to gain insight into your network traffic and identify potential security threats or issues. You can store flow logs in S3, in CloudWatch, or you can also support third-party logging solutions. Once those logs are stored, you can then use tools like S3 Athena, CloudWatch, or Elasticsearch to query and analyze the data. They can be super handy for diagnosing any network connectivity errors, as you'll be able to see what steps a packet has successfully got through and where it may have failed and been met with a response such as a deny. Next, we have WAF, or Web Application Firewall. This is not strictly a VPC level technology, but WAF can be linked to resources inside your VPC, such as application load balancers. Web Application Firewall can be used to protect your web applications from common exploits, such as SQL injection or cross-site scripting. You can also create things like geographical restrictions, so block any traffic from particular countries, and enforce rate limiting using this service. You can also define your own custom rules based on things like the presence of query strings or certain headers in requests, so it's definitely worth understanding and applying WAF to any internet-facing resources. Network Access Analyzer provides detailed visibility into the traffic within your VPC, including traffic patterns, sources, and destinations. It uses algorithms to analyze the different network paths that packets can flow between on your AWS network. It works quite closely with VPC flow logs, but one key difference is that by using this service, you can get insights on what security group rules allowed traffic past a particular checkpoint, rather than just seeing that as an allow entry in VPC flow log rules. And finally, the last VPC security technology that I'm going to cover in this session is AWS Network Firewall. Network Firewall allows you to create and manage firewall rules to filter network traffic and inspect traffic in real time to identify and block threats before they reach your applications or resources. The service also includes built-in threat intelligence from AWS and third-party providers, which helps you to identify and block any known malicious traffic, for example to an external web address known to be linked with bad actors. A key use case for Network Firewall, which you weren't able to do natively in AWS until more recently, is that you can create rules that define allowed and denied traffic based on a variety of criteria, including IP addresses, ports, protocols, and domain names. It used to be the case that if you wanted to block traffic based on domain names, you would have to implement a third-party solution, but Network Firewall now provides you with that capability. And that brings us to the end of today's materials. So in conclusion, we first looked at setting up a new AWS account and how you can secure your root user after performing some very limited setup activities such as enabling CloudTrail with MFA delete. You should avoid using the root account for any day-to-day activity. Instead, you should be using an IAM administrative user who can then go on to create other users, groups, roles, and policies. IAM is a key AWS feature to understand in depth, as it is the core identity management service used by the platform. You can use wrapper services such as Security Hub and Firewall Manager to aggregate security findings, which makes it simpler to assess findings and remediate. But as we also saw, there are numerous account-level security technologies, each which support different levels of customization for your use case. We then moved on to VPC level considerations, and it's important to note that network design is a really key consideration, and there are some core monitoring technologies you should understand and enable in your VPC, for example, VPC flow logs. Finally, just a reminder that you can keep up to date with the latest emerging security advice and technologies by tracking the AWS Reinforce conferences. I hope the session was useful, and as always, I'm very happy to hear any constructive thoughts, feedback, or comments you might have on these materials. But for now, that's me signing off, and thanks for listening.